Airplanes release significant greenhouse gases and other pollutants, contributing to climate change and air quality issues. High-altitude emissions can have an amplified effect on global warming. While major cities are usually well connected by air, remote or rural areas may lack nearby airports, making it inconvenient for people in those regions. Airports, runways, and other facilities require significant land and financial investment, impacting local landscapes and often causing displacement of communities or wildlife. Earth-to-Earth space transportation is an exciting concept that aims to revolutionize long-distance travel by using suborbital spaceflights. Instead of going into orbit, these flights travel to the edge of space and then descend back to Earth. This allows for much faster travel compared to traditional aircraft. Companies like SpaceX and Blue Origin are developing reusable rockets that can carry passengers and cargo between different points on Earth. Let's see how it works. Thrust and propulsion. Launch vehicles rely on powerful rocket engines to produce thrust, which is the force needed to propel them upward. They use either liquid or solid propellants, or a combination of both, stored in tanks. When the fuel and oxidizer are ignited, the resulting controlled explosions create high-speed exhaust gases expelled downward, pushing the rocket up according to Newton's third law. For every action, there's an equal and opposite reaction. Achieving orbital or escape velocity. To reach space, a launch vehicle needs to attain either orbital or escape velocity. For Earth orbit, it must reach around 28,000 kilometers per hour, 17,500 miles per hour, to enter a stable orbit. Staging for efficiency. The launch vehicle is two-staged, meaning it has separate sections, stages, that ignite and detach sequentially during the ascent. The first stage of the rocket contains engines and fuel tanks that provide the initial thrust to lift the rocket off the ground. The second stage carries the re-entry vehicle into orbit. Once the vehicle reaches the desired altitude and velocity, it releases the re-entry vehicle into orbit. At this point, first stage rocket uses its remaining fuel to fire its engines in a controlled burn to slow down and reorient itself. As the rocket approaches its landing zone, a final engine burn slows it down further for a precise landing. A guidance system directs the re-entry vehicle's path, ensuring it follows a precise trajectory. This system uses gyroscopes, accelerometers, and computer algorithms to constantly monitor position and adjust thrust direction, allowing for course corrections. The control system manages these adjustments through gimbaled engines that tilt to steer the vehicle, and small thrusters to keep the vehicle stable. Engine on the second stage reignite to guide the rocket back towards the landing site. This phase is called the boost back burn. As the rocket re-enters the Earth's atmosphere, the engines ignites to slow down the descent. The small thrusters stabilize the re-entry vehicle and control its direction. Just before touchdown, the final engine ignites to slow the rocket to a near hovering speed of about 5 miles per hour. 4 landing legs made of carbon fiber and aluminum unfold to stabilize the rocket. The re-entry vehicle lands vertically on a concrete pad called the landing zone at the Space Center. Pros of Earth-to-Earth space transportation. Unlimited accessibility. Unlike air transportation that depends on sophisticated infrastructure, including airports, air traffic control systems, and runways, which can be expensive to build and maintain, launch station can be built on relatively smaller spaces. Reduced environmental impact. Hydrolox is a combination of liquid hydrogen and liquid oxygen, both of which can be produced by splitting water sustainably. Nitrogen-based rocket fuel can be helpful to reduce global warming. Reduced flight interval. Trips between major cities, which currently take 12 to 15 hours by air, could be completed in less than an hour. Example, New York to Shanghai in 40 minutes. Cons of Earth-to-Earth space transportation. High costs. Rocket design, construction, and operation require significant financial investment, often limiting access to only governments and wealthy corporations. Health hazards. Noise pollution, toxic fuels, and environmental contamination during launches can harm nearby communities and ecosystems. Safety challenges. Rocket launches carry high risks. Explosions, malfunctions, or crashes can lead to loss of life, equipment, and resources. Geopolitical concerns. Rocket technology can be dual-use, civil and military, leading to concerns over weaponization and international tensions. Rocket aviation represents a transformative step in transportation, offering unparalleled speed and accessibility compared to traditional aviation. However, significant challenges remain, including high costs, safety risks, and geopolitical concerns. Future advancements aim to improve cost efficiency, reduce environmental impacts with sustainable fuels, and enhance safety measures. As technology evolves, rocket aviation has the potential to redefine global connectivity and open new frontiers in both commercial and humanitarian applications, fostering a more interconnected and advanced world.